Hi there. Welcome to Pallet University. So, this is a little bit of a warning up front. This video is going to be pretty technical. I'm going to try to make it as easy to understand as possible, but we're going to be talking about some pretty in-depth science things here, so there's only so much I can do. So that's just sort of a warning up front for you guys, but hopefully that's what you come to this channel for anyway. So hopefully you'll enjoy it. Anyway, so if you watch this channel, I'm almost positive that you're probably familiar with this series from Birdkeeper Toby, which basically is where he takes all Pokemon and puts them on an evolutionary tree of life, making what we in the sciences would call a cladogram. Basically, separating Pokemon, or, in the real world, animals or plants or whatever group you happen to be looking at, into groups based on, a common ancestor. So if we have species 1 that evolved into 2 or 3 species through, evolution by natural selection, all of those would be in a group. So basically he took Pokemon and put them on this kind of tree of life. However, I've had some reservations about not anything that he did in particular, but the fact that, these aren't animals. These are Pokemon. And I've had just very brief conversations with a few other people, through Twitter or through YouTube comment sections, about this fact that these are not animals. And, we shouldn't treat them as if they have the exact same biology as the organisms that we have in our world and classify them as if they do. Which makes a lot of sense to me. So, this semester, in my graduate school, in my the classes that I'm taking this semester, I'm taking one called Phylogenetic Systematics, which is essentially how scientists go about making these trees. And through this class, I've been given access to a couple pieces of software and, trained into how to properly use them to make trees like this. So that's what we're going to be doing in just a very small sample of Pokemon here today. So first, let me run down a couple of basics. One of the basic principles of using these softwares to make these trees is that the more organisms, or taxa as we would call them, the more taxa you have, the more possible trees you can get, which just makes sense, but it's really exponential. If you add one more taxa, you get many times more trees possible. So think of it like squaring something. So if you take 10 squared, which is 100, you go up to 11 squared, which is 121, and then you go to 12 squared, which is 144, it gets, the amount of increase, even though you're going up 1 squared each time, the amount of difference between the end result gets bigger and bigger each time. So it's similar to that. So there is not necessarily a limit to how many taxa you can have, but there are some sacrifices that you have to make if you're going over a certain threshold of the number of taxa that you're using. Typically what we've done so far in all of our lab exercises for this class is use 12 taxa, which is sort of the maximum limit that you can use to still have pretty high resolution and pretty high confidence in the tree that's being made. So that's what we're doing here today. I went to an online random Pokemon generator, and I had it spit me out 11 Pokemon, and I'll talk about why only 11 in just a second. But spit me out 11 Pokemon, and I basically used this software and the training on how to input data into it to make a tree using these 11 Pokemon. And eventually, once I have enough free time, I would like to do this to all final forms of Pokemon. So if the maximum number of taxa you can use for this good high resolution tree making is 12, why did I only generate 11 random Pokemon? Well, that's because you always need to designate something as an outgroup, which is the closest related taxa to the group that you're looking at that is not included in that group. So I'll give a real world example. So if I were looking at great apes as my group that I was interested in, which for modern great apes includes humans, chimpanzees and bonobos, gorillas and orangutans, my out group would be one of the other apes, which would be gibbons or Siamangs. So basically, it's the closest related group that's not in the group you're looking at. So because of this, I had to add the extra one to make it 12. And I decided for basically every test I'm going to end up doing with this that my outgroup is going to be Reuniclus. Because Reuniclus seems to me to be the most basic Pokemon, because it's essentially supposed to be just like a group of cells, is what I kind of interpret it to be. And that would, in my mind, be the most basic kind of organism that Pokemon has given us so far. So, with that bit of terminology out of the way, what Pokemon did the random generator give me? Well, it gave me Purugly, Swellow, Golem, Suicune, Farfetch'd, and I guess you could use Sirfetch'd, although we don't have as much information about Sirfetch'd, so I decided to use Farfetch'd instead. Sharpedo, Venusaur, Granbull, Illumise, Togedemaru, and Liepard. And of course, Reuniclus. So what kinds of information do you need to put into this in order for it to give you a tree? Obviously, you can't just, copy-paste like a Pokedex entry into this thing and have it interpret it. Number one, there's not nearly enough data in Pokedex entries. I've looked. And also, that's not how these programs work. These programs basically read binary code, or pretty close to it. So what you have to do is you have to separate their characteristics into things called characters, which are basically just something about the organism that changes from taxa to taxa. So I'll read you some examples, and I'll actually put my entire list of characters on screen. So for my characters, I decided to choose skeleton, which can be internal, external, or absent, which, you think something with bones has an internal skeleton, something like an insect or an arthropod has an external skeleton, and with something like Reuniclus, which you also have to, apply all these characters to, does not have a skeleton. It does not have internal or external, it's just kind of a cell. For our second character, we did external covering, which is whether it's got hair, scales, feathers, chitin, which is what bug exoskeletons are made out of, or not having one, once again. Ears can be either internal, external, or absent. Respiration, that can either use gills, lungs, or not really have a clear structure on how it works. Teeth can either be present or absent. Character number 6, we had circulation system, which can either be closed, open, or not really applicable, again in the case of Reuniclus. Forelimb to hind limb ratio, which can tell you a lot about how an organism moves in its environment, where it can be either 1 to 1, which is they're about equal, greater than 1, which means that their arms are much longer than their legs, or greater or less than 1, which means that their back legs are longer than their front legs. They can either have or not have chlorophyll. They can either have 2, 4, or 6 appendages. 6 is there because I considered Illumise's wings appendages. The organism can either mega evolve or it can't. I wasn't sure if this would become really relevant at all. But with these kinds of things, with the characters, you don't know which ones are going to be relevant and which ones aren't. So it's best to just include everything that you possibly can. Osteoderms, which are little pieces of bone inside the skin used for defense. They can either be present or absent. Number of evolutionary stages. You can either be like a single stage, such as Illumise. You can either be 2-stage, such as Swellow, because it has 1 pre-evolution in Talo. Or it can have 3 stages, such as Venusaur, which has Bulbasaur, Ivysaur, and Venusaur as the final. The presence of a water storage organ for using things like water attacks outside of water. There's a similar character for electricity generation, using things like, Thunderbolt, Thunderwave. Basically how I measured this one is if it learns more than 3 electric type attacks. I just kind of assume that it must have some way to generate electricity. That's a completely arbitrary number, and that one could be definitely up for debate. It was just something that I thought was kind of important because that's a really unique feature in our, real life biological world. Very few organisms can actually generate electricity, so I thought it was pretty important. And then finally, claws. They can either be present or absent. I decided this one based on if you could physically see claws, or if you can't in any of its artwork, if it learned, again, 3 just for consistency, like claw slash scratching type moves. So you take all of the information from those characters and you apply them to each taxa, and you form a matrix that looks something like this. I color-coded them just because I think it makes it easier for me to read, Hopefully it makes it somewhat easier for you to read too. And you can go through and, if you feel the need, you can go through and compare my list of characters to how I applied them. If you have any suggestions for characters, and I'll ask again at the end of this episode for character suggestions, because the more characters, the better. But like I said, we'll get to that later. So, what were the results, you might ask? Well, first, let's see what the tree should look like if they are classified based on the organisms that they're based off of. So here's the tree that I just kind of threw together really quickly, with Reuniclus being toward the bottom because it is the outgroup, which is traditionally where the outgroup goes. Next we would have Illumise, because everything else on this list is a vertebrate, and Illumise clearly is not. It's an arthropod, it's an insect, so it goes toward the bottom. Next up, we have Sharpedo, who is the only non-tetrapod left. It is a cartilaginous fish based on a shark, so that is not in the same group as everything else, which is a higher vertebrate. Next up, we have the sort of reptile branch, with Golem coming off more of the base. I believe Golem is sort of based off of a turtle or a tortoise, pretty loosely based off one of those, but it looks much more reptilian than it does mammalian, definitely. And since birds are reptiles, I put Farfetch'd and Swellow on this branch as well. Next up we have Venusaur, who, if you have not seen the first ever video that I put on this channel, Venusaur is not a reptile, it is also not an amphibian, it is a synapsid, which is, in real life, the ancestors to mammals. So it's more closely related to mammals than to reptiles, so I didn't put it on the reptile branch. Instead, it is included in the same group as all the rest of the mammals on the list. Next up we have Togedemaru, who is based off of a rodent, and it is next because everything else that's not been discussed so far is either a dog or a cat, which are in the order Carnivora. So with it being a rodent, we decided to put Togedemaru first and all the carnivores next. Then on the next branch is the dog branch, which is Granbull and Suicune, and the next one being the two cats, Purugly and Liepard. So that's how it would look if everything was classified purely based off of the real world animals that they are based off of. But what did the software analysis of these organisms give me? So this is what it gave me. Reuniclus will always be at the bottom because I tell the software to put it there. I tell it that it is the outgroup, and then based on that, it constructs the rest of the tree. Illumise stays where it's supposed to, so we have a pretty strong start. And then pretty much everything falls off the rails after that. Suicune was put on the same branch as Farfetch'd and Swellow. I'm not really sure why. I think it might be because of the teeth character, because everything else, sort of up the branch from here was marked as having teeth, and nothing below it is marked as having teeth. And yes, Suicune can learn Bite, or I think it learns Ice Fang as well, but also so can turtles. Turtles can bite things in the real world, and they don't have teeth. So I didn't think that. Plus it only learned the 2, and if I was using 3 moves as my threshold for the Electricity Organ and the Claws characters, if it only learns those 2, I wasn't really inclined to just assume it has teeth. Plus there's pictures of it with its mouth open, and it very clearly does not have teeth. So I think that's why it put it on the same branch as these 2, but I'm not quite sure. As for the rest of it, I honestly don't really know. It doesn't tell you precisely why it put each organism where it does. I'm assuming that it put, Venusaur, Sharpedo, and Golem at the end because that forms a group that all has scales. Whereas I'm not really sure why it didn't put everything that's got fur on the same branch. I'm not sure why it did that. Especially because I believe that Liepard and Purugly had almost everything exactly the same as it, when it comes to putting things in the software. So I'll have to look a little bit more into that. But from what I could tell, it didn't really give me a very specific reason. And that is one of the problems of using some of these, softwares, because this was not the only tree that it gave me. In fact, it gave me 7 trees that, the first one in the list is generally the one that's best supported, which is the one that I've been talking about for the last minute or so. But it's not the only one. And there's an option for you to compute what's called a consensus tree, which sort of does its best to combine all of them into one that's reasonably confident. So I had to do that, and the results were not very encouraging. So here is that consensus tree, and as you can see, it starts off pretty much the same, with Reuniclus and Illumise down at the bottom. It has Suicune still closer to the birds than to, the other things that you would assume would be more closely related to, because I believe Suicune's supposed to be based off of some kind of dog or cat or something like that. But we get into now what are called polytomies. So as you can see, the branch that Suicune branches off from the birds is much lower and basically on the main trunk of the tree compared to when it was before. And that's called a polytomy, which basically means it's a point where there's a split of more than one branch from one point. And what that means is that the computer does not know how to resolve this. And you can see that there's a very extreme polytomy with everything that is upstream of the birds. And this is not a very pretty diagram. Perugly is included in that big mess of all the other ones. This was just how the diagram that I drew happened to work out, but Perugly is included in that. And that's not a very good sign. If your consensus tree basically just gives you a bunch of polytomies, we call that a rake. Because, as you can see, you might be able to see the pattern from that big polytomy starting at Liepard and going to Golem. It sort of looks like something you would use to rake up leaves with, which is not good. We try to make it look like a very good tree, like we had at what it should have been, the one that I made just sort of from scratch. It's ideal for them to look like that. However, that's almost never how it actually works. Even with real life organisms, that we have all this good information for, a lot of times you can still get rakes. And it's really frustrating. I'm lucky enough that the data that I was using for, what I was being graded on for this class, we basically just had to pick something. Like, one of my classmates did his with desserts, because he likes to bake. One of my other classmates did it with, I don't remember what she did hers with. I don't know. I should really ask her. I did mine with computers, pre-built computers that I found on newegg.com, because I'm a computer nerd. And mine turned out actually perfect. There was, the exact amount of data, basically, for each thing that I needed for it to turn out well. And what this tells me is that I need more characters. So that's where you guys come in. If I'm going to be doing this with all, seemingly, I believe there's over 500 to 600 different, Pokemon taxa, which would mean, the final stage, basically families, Pokemon families, that I would need to do this for. And I would like to have at least 20 to 30 characters at minimum. And, I had some trouble coming up with even the 15 that I used for this. Normally, in the one that I used for class, we were required to have 20 characters, but it gets into things like, you can't have, characters that interfere with each other, really. So you couldn't use something like, the best example is Tails. You can't have one character that says tail, present, absent, and another one that says tail, short or long, because if, the first character, has a value of absent, what is the value of the next character, whether it's short or long, going to be? You can't use that. And generally having characters that have an option of not applicable is not ideal. And I had a couple like that, mostly because I couldn't think of anything else. So that's where you guys come in. If you have any suggestions for characters to use, definitely let me know down below. There was one paper that we had to read for this class where I think they only had something like 20 to 30 different taxa, but they had over 400 characters. And that makes your analysis so much more, robust, so much more like thorough, basically. So having only 15 characters makes it not very thorough, and that's why I would like to at least double it when I do the full big scale analysis. So I'm positive there will be more videos from this channel on this topic, but I just wanted to put this in your guys' ear now that I will be working on this, you know, periodically whenever I've got free time. And as beautiful of a figure as Birdkeeper Toby's tree is, and if the option is still there to buy one, I definitely would recommend buying the poster. But it might not be the most reflective of what we actually see in the Pokemon world. And obviously, this kind of analysis that I'm trying to do will never be as complete as one that we could do in the real world, because I'm never gonna get my hands on, you know, a Venusaur skeleton, obviously. But I feel like with all of our collective minds from the internet, we could do a pretty good analysis. So that is going to do it for this episode. Thank you guys very much for watching, and like I said, let me know your thoughts. I've got some preliminary thoughts on how to go about doing it. I think what I'm going to do is sort of split it up into different subgroups, which is less than ideal, because then that relies on me deciding to include these ones in this analysis and not these ones. So it's kind of tough to do that and then stitch the trees together, because that involves my bias in it. But personally, I kind of trust myself with knowing a fair amount of basic biology and which animals most likely would be most related to each other or not. But I guess we're gonna see. Anyway, make sure to follow us on Twitter at Pallet_U to keep up on all things Pokemon science. And as always, there's a time and place for everything.